So here we're going to look at quadratic equations and complex numbers. So first we're going to solve one that has two real solutions. It says solve 3x squared plus 5x equals 10 using the quadratic formula. Remember we want the ax squared, want it to look like ax squared plus bx plus c equals 0. So we need to set it equal to 0. That means we need to move this 10 to the other side. So that's plus 10, so the opposite of adding 10 is subtracting 10. And then we have 3x squared plus 5x minus 10 equals 0. So let's label our a is 3, our b is 5, and our c is negative 10. All right, now we're going to substitute those numbers into our quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah. All right. So we have x equals negative, and our b is 5, plus or minus the square root of 5 squared minus 4 times a is 3 times c is negative 10. And all over 2 times our a is 3. So there we have x equals negative 5 plus or minus the square root of 25 minus, and then negative 4 times 3 is negative 12, times negative 10 is positive 120. All over 6. 25 plus 120 is 145. And is 145 a perfect square? It is not. So what we're going to do is we're going to split this up. We're going to calculate it using a calculator. X equals negative 5 plus square root of 145 all over 6. And it's going to be a decimal, so it's going to be approximately. And we're also going to do x equals negative 5 minus square root of 145 all over 6. And it's going to be a decimal as well. So let's plug that in. Okay, so we have parentheses because we're going to work with the numerator first. So negative 5, negative plus 145 square root, oops, shift square root, close parentheses, divided by 6 equals, and you can use desmos.com/scientific as well. So 1.17. 1.17. All right, and the next one, same thing. So we need parentheses for the numerator, 5 negative, and then minus, and then 145 square root, so shift x squared, close parentheses, divided by 6 equals negative 2.84. And there we go. Our two solutions. All right. And those are still real, even though they're decimals. So those are two real solutions. Let's look at one that has one real solution. It says solve x squared plus 3x minus 7x minus 25 using the quadratic formula. So just like before, we need to make ax squared plus bx plus c equals 1. So we need to solve for, we need to get it equal to 0. Sorry, equals 0. I think I said 1. All right, so I'm going to move all these terms to the other side. So we're going to add 7x to the 3x, and we're going to add 25 to 0. We have x squared plus 3x plus 7x is 10x, and then plus 25, that's a constant, equals 0. There we go. Our a is, remember, if you don't see a number in front of the variable, it's a invisible 1. And we have a b. Our b is 10, and our c is constant 25. Let's plug it in. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright. So we have x equals negative b. Our b is 10 plus or minus the square root of 10 squared. B squared minus 4a is 1 times c is 25 all over 2 times a is 1. So there, we can simplify that to negative 10 plus or minus, and then we have 10 squared, which is 100, and negative 4 times 1 is negative 4. Negative 4 times 25 is negative 100. Uh-oh. Yeah, all over 2. We get x equals negative 10 plus or minus, and 100 minus 100 is 0, so we just get 0 there, divided by 2. So we're left with x equals negative 10 divided by 2, which is just one solution, negative 5. And that's it. So this one, it only the vertex, right, touches at negative 5. That's it. Okay, let's look at the last one. Solving with imaginary solutions. So solve 5x squared plus 7x equals negative 3 using the quadratic formula. Again, move this plus 3, move the negative 3 over by adding 3. You get 5x squared plus 7x plus 3 equals 0. A is 5, b is 7, c is 3, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And we're gonna substitute those numbers in. Our negative b, so negative, our b is 7 plus or minus the square root of b squared, so 7 squared minus 4 times a times c all over 2 times a is 5. Alright, so we have x equals negative 7 plus or minus square root of 49 minus, and then negative 4 times 5 is negative 20, times 3 is negative 60, all over 10. And there we get x equals negative 7 plus or minus the square root of negative 11 over 10. And then we get x equals, because we have a square root of a negative number, remember, I take away all negatives, so it's negative 7 plus or minus I root 11. And if you're wondering where that came from, remember, we can split negative square root of negative 11 into negative 1 times 11, and the square root of negative 1 is a, and the square root of 11 just stays square root of 11 all over 10. And that's it. So there's 2 of them there. Negative 7 plus I root 11 over 10, and negative 7 minus I root 11 over 10. That's it.